we'll deal with that first, and then we'll come back and hit the other ones. Okay, so for you guys that were here yesterday, we have two things. We take a point through a pole, and I'll show you the pole, how we plot it in a minute, but we rename them two ways. We take the radius is a directed distance. We take the angle, we have a point like this. So we take the angle plus or minus 2 pi, but it has to stay in the negative 2 pi to positive 2 pi range here. Then we negate the angle, and we do plus or minus pi. We negate the radius, but technically we can't plot. I'll get to that part in a minute, but that's how we rename it. That's where they're coming from. Now the reason we cross these out is because it's out of the 2 pi range, whether it's the positive way or the negative way. It's out of the 2 pi range. Any questions on these guys? Everybody can find the points? There's one of them on the final, so just rename the points.
There's a wait for numbers?
Yeah, there's not a lot of these. There are a couple of equations. Polar solutions. What's that?
How do you decide which one you're going to make the
Well, you start with this. You start with whatever it is, and you take the angle, and you add and subtract 2 pi. And now, when I get to these two, this is within my range of negative 2 pi to positive 2 pi. This is out, because if I convert this to fourths, then I'm looking at 8 pi over 4 to give me 2 pi. So anything out of the 8 pi or the negative 8 pi, I can't keep. So I get rid of that. Then I take this guy, and the only thing I change is this negative sign. And you're going to see in a second, we can't plot that, but it's directly through the pole. It would exist.
So always, like, when you're adding or subtracting pi, you make it, like, the opposite
of whatever the radius says. And if it starts out negative, we still add the 2 pi first. When we negate this, it becomes positive, we add the pi. Do you see it, Noah? Yeah. Okay. So we're just taking these guys. As soon as we change the sign on this, whether it's positive to negative or negative to positive, we add and subtract pi. This again is out of my range. I can only go 8 pi, whereas 8 pi to 8 pi over 4, and this one's okay. Sometimes you get all 4, sometimes you get 3, depending on where your angle is. This one started out negative, and that's okay. I still add and subtract 2 pi. When I change the sign, I negate that. It becomes positive. I add and subtract pi. This one got moved around a little bit. Something happened with my word. I had to shift them around a little bit. And the last one, we have a negative angle. The negative angle just means that we go this way. But we do the same thing, same process, add and subtract 2 pi. Once we negate it, just add and subtract pi. Simple rule. Just remember that simple rule. Okay. All right. The next 4, 3, 3. The next 3 we can put up here. Again, whatever you start with, add and subtract pi. Negate it, change the sign, add and subtract 2 pi, then change the sign, add and subtract pi.
I don't get the one for the 12, like how you know.
Which one?
Like number 5.
Like number 5. Okay, so it's the same process. It's the same process, you just have to convert this to 12ths. So this would be 24 12ths, 24 pi over 12. You're just converting it. Same exact process as if it was one of your favorites, over 3 or over 6.
But how do you know if it's in the 2 pi range?
Because it can't be bigger than that positive or less than that negative. Once you convert your 2 pi, it can't be out of this range. The same thing you do here. So you convert this to 6s. So you say, okay, I can go as far as negative 12 pi over 6 to positive 12 pi over 6.
Oh, that makes so much more.
Because you're kind of setting your 2 pi right there. So as soon as you set your 2 pi, that's as far as you can go.
So much easier.
And your pi, usually your pi works except for in like extreme cases where your angle is a little bit off. This is a very small angle. A lot smaller. And same thing with this guy. Same rule all the way through. No, you just negate this one. You negate the radius. You just negate the radius. We still kept this. This was a negative angle. We still kept it negative. But when you add and subtract pi, you're going to add pi to it, then you're going to subtract pi from it. Sometimes it actually becomes a positive when you're adding to it, because it depends on where it is at. Okay? I think the harder concept is the graphing part. So when you graph this, you're only getting 1 point for each one. So let me see if I have an answer for you and I can talk about put the point up here. I don't know if I do. I do. This one, yeah. Where? Here? Ah, nice of you guys to come in. You couldn't find the parking space this morning?
Yeah,
Ah.
we parked all the way in the corner.
So Danny, your partner in crime with Chris?
Yeah.
I'm shocked. So this was number 1. Okay, so let's just talk. I'll do 1 positive, 1 negative. This way you see where it's going. So this is my radius, directed distance. So come out to the 3rd radius. This is the 3rd one. I'm coming around. Excuse me. I'm coming all the way around to 5 pi over 4. These are already labeled for you. 5 pi over 4. So I come to here and I put a dot. That's the only dot I can make. The negative one exists through the pole, but I don't put a point there. It's just a way to name it through the pole, but I only get 1 dot, the positive radius, because I can't graph a negative radius. Because your radius is the distance from the center to the edge on the circle. So it's a distance. The second one has a negative. Okay, I can't graph this one because I can't go -3. So I look for one of my positive ones. And I have 3, 5 pi over 6. This is why you converted this. You can graph this one. So if you bring this up to the 3, again, they make me blind when I stand too close to these rings. So come out to your 3rd ring and find 5 pi over 6. Here's your 5 pi over 6. There's your second point. Through the pole, it would be down here. So if you went like this and you graphed this angle, 11 pi over 6, know that you can't put it there. Just come straight through the pole and put it on the positive side. That's all you have to do. Just remember, you can only graph the positive radius.
I wonder how you graph 5 and 6.
5 and 6. Okay, so let's look at 5. Don't like those negative angles, huh? Okay, so I'm on a radius of 5. So I'm coming out to the 5th ring. Good. Now, take this. This would be my 0. This would be 12 pi over 12. And 12 goes into 180 how many times? 15. So if this is my 30-degree angle with the 6, this would be my 15-degree angle. This would be my 11 pi over 12. How do I know? Because from here to here is 30 degrees.
Yeah.
So half of 30 is 15. So see how they leave a little space in between sometimes? Well, okay, look from here to here. Here's a 30 to a 45. 15-degree difference, right? So flap this first. Come negative all the way around and stop right one before it. That would be 11 pi over 12, negative 11 pi over 12. These are kind of separated by 15s, but we usually just use the 30s. But you can see right here, the 45 to 30. Okay, so just come the opposite way. And number 6 is a little different because it's a negative angle, that's going to stay. So if I made an attempt to graph this, and I did the -3, and I did this angle, -13 pi. That would put me over here, and that would put me here at the 3, but I can't plot the negative. I got to go through the pole and plot the positive. Or just pull up one of your positive conversions. You can still try, like you can still do this, but just send it through the pole. Don't plot it on the negative side.
But how do you know to go to that?
Because of this angle said start here, come negative,
Oh.
come past the 12, and one more to the 13. Just label, the best way to do that is label these pi and 0 as your, keep your denominators out there.
Wait, for number 4, like,
So number 4, you can't graph that one either. Because it doesn't exist with a negative. But if you found this on the 5th ring, 7 pi over 6, and you came out to the 5th ring, you can't plot it here, but you can go through the pole and plot it.
I think the function.
Because it's a negative radius. Convert it first, use your plus 2 pi, plus or minus 2 pi, then negate it, make it positive, and use your plus or minus pi. You can graph one of those. And that would come out to be 5 pi over 6. But you can kind of like still find it on your graph, just don't put the point on the negative side, go through the pole and plot it. Okay? We'll just wait for this. So I think all right, so today we're going to go from polar to rectangular, rectangular to polar for the points. Tomorrow we're going to do the equation part, polar to rectangular, rectangular to the points. So let's just hit this part, and then tomorrow we'll hit the equations, and that's really all I want you to get up. All right, now, because we're working with angles, and because we're working with different parts of your angles and their radians especially, it kind of leads you to think you got to do a little bit of trig here. So we know that the x is associated with the cosine and the y is associated with the sine. And because it has a different radius, your radius is coming in here, is coming into play. When we go the opposite way, rectangular to polar, we need to know something about our angle. And because we're on an xy grid, the one function that deals with x and y happens to be tangent, right? Because it'll take your points, your xy point, and we can find the tangent, therefore we can find the angle. The other thing that works with the radius, these guys, is your circle. So that kind of makes sense to use those two things when we convert the opposite way. You'll see them. And the first one we're just going to go is just take the point and convert it from polar to your rectangular or your xy point. It just gives you an xy. The best way to do this, too, is with a sketch, because you're going to see this as we sketch it. So if I convert 2 pi to a rectangular, let me just graph this first on my polar. So I only have to come out to radius of 2, right? So I come out to a radius of 2 and an angle of pi. It would be right there. So what would you guess would be the xy coordinate for that guy? -2, 0. Makes sense, doesn't it? So let's convert this. Let's use these two formulas. Okay. So we're going to take your angle. In this case, this is your R, this is your angle. So we're going to put this in. 2 times the cosine. I'm just going to substitute it in right now. Okay, so we have to remember just a little bit about this. So I know on my pi, this is -1, 0, xy, cosine, sine. So what is the cosine of pi? And you can even put this in your calculator, cosine of 180. What's the cosine of 180? -1. So I'm going to replace this with a -1. Ah, And Anne-Marie told me my x would be -2. Good so far. We need a y. What is my sine of 180? 0. And there's my y, 0. So there's my point. My polar to rectangular. But you can kind of almost see it on the graph. You can almost, because it's your xy axis superimposed across your, like we took that globe, don't forget, and we flattened it out. We have your xy axis. We rotate all your angles all the way around in a circle, and we go through all your radius the same way. Make sense? Okay. Let's try another one. So I'm going to kind of graph this guy. This is about like 1.7. So somewhere in the middle here, I have a point. So I'm somewhere in the middle like this, and I'm probably, the 30 degrees is probably over here somewhere. I've got to get that xy point. So I just use my formulas. If it helps you, go like this. Label those r and theta. This way you don't say, where do I get my r from? Where do I get my angle from? You'll see it right here. So put your r, which is radical 3, and the cosine of pi over 6. This is where you have to use your exact values. So pi over 6, what angle is that? 30-degree angle. So I know my 30-degree angle. Says this is 1, 2, radical 3. So what's my sine of 30? One half. What's my cosine of 30? Radical 3 over 2. So I know both of those parts, right? So I plug them in. Radical 3 times my cosine, radical 3 over 2. And a radical 3 times radical 3 is 3. It just pops right out. Radical 3 times 1/2. What would that give me? Radical 3 over 2. So here's my point. So my point is 3/2 radical 3 over 2. And it was kind of sticking out there in the middle of somewhere, wasn't it? So could you kind of see the 1.5 almost? Past the 1? Kind of almost to the 1.5? Radical 3 is 1.7, so half of 1.7 is like less than 1. So it makes sense? And it would be located in quadrant 1. Just kind of place it. Okay? Now, the second one, we have two other formulas for. We're going from rectangular to polar. So rectangular to polar said this in the first page. You need to get a radius, you need to get an angle. So we have two things that deal with the x and the y's. We have a tangent of an angle, and we have the equation of a circle. That will help us get this part. Okay? And the x and the y will help us get your angle. Good? Now, if we graph this, -1, 1, somewhere up there I am. This gives you a good place to set the point of reference. So when we graph this, we're going to say this. I need to know my radius, and I need to know my angle. So either one you can do first. So we're going to find your radius. Your radius is always going to be positive. And it's always going to be positive because as soon as you square a negative number, you get a positive number. So I take my x, put x and y. So this gives me what? This gives me 1 plus 1, 2. So my radius is radical 2. Agree? Okay. So I can be a radical. Doesn't have to be exactly on the radius. And then we have to find your angle. So to find your angle, we say tangent of an angle, y over x, We take your y over your x. So what quadrant is my point gonna fall in? What quadrant is that point -1, 1 in? 2. So this is going to tell me which quadrant I need for the tangent of negative. So tangent is negative in 2 and 4. But which one do I need? 2. And if you remember this guy, this was a 45-degree angle, right? So this is a pi over 4. This is 4 pi over 4. Because the sides are equal, 1 and 1, right? So I have 2 special triangles, and I'll write them down again for you guys. Now, when my angle comes like this, so what is my angle going to be? I'm 1 short of 4 pi. Good. 3 pi over 4. It's kind of bringing back a little bit of your trig. So, radius, angle. Radical 2, 3 pi over 4. There's your polar point. Make sense? Okay. Your 2 special triangles. 30, 60, 90. Opposite the 30 is 1. Opposite the 60 is radical 3. Opposite the 90 is 2. Your 45, 45. 1, 1, radical 2. And kind of remember your quadrant angles. 1, 0. Just do this again all the way around. Just a little refresher. Remember x, y, cosine, sine. And you can put your quadrant angles in your calculator because they're all full numbers, 1s and 0s. But the other ones you're going to need your radicals with. So one more. If we take this point, x, y, let's just find this point. 0, 2. Can you almost guess what your polar coordinate's going to be? Pi over 2, because that's the 90-degree angle, isn't it? And what's my radius going to be? 2. So 2 pi over 2. Let's see if this works out for me. I find graphing it is the best thing to do because it actually brings it into perspective. You can see what you're looking at. If you don't graph it, it's kind of so abstract looking on polar coordinates. Because what angle goes from here to here? I'm just saying, let's try to see if we can estimate where it's going to be. And when it's here in the middle somewhere, we really can't. We know that it could be anywhere in quadrant 2 angles, but so we do know the tangent's negative, the sine is positive, the cosine's negative. But when we get to a quadrant, we can kind of tell those angles. But we're going to plug it in anyway. So this is your x and your y. So radius squared is 4. So your radius is 2. So that's your first one. Your angle, you're going to say your tangent of your angle. These are the only things you're given, y over x, the y and the x. So we have to work with those guys. So we say y is 2 over 0. So it has an undefined, it has an angle that's undefined, sorry. My tangent is undefined. My tangent is undefined at 90 and 270. So which one am I looking at? 90. So your angle, just put it together. Make sure you put them together at the end. 2 pi over 2. And we could almost kind of see that from your graph, right?
How do you know where it's undefined?
Because tangent is undefined up here, because if you do this, xy, 1 divided by 0, you can't divide by 0. So your tangent is undefined at the 90 and the 270. It just was multiplied by 2 for this guy. Okay, so tonight you're just going to take some points. Keep this handy. Make sure you use them.